In today's lesson, we are going to learn how to determine the equation of an hyperbola when we are given the graph. Now let's quickly look at the information here. Now our hyperbola is drawn in the first and in the third quadrant. So what do we know from that? We know that a is going to be a positive value. We are also given this extra point on the hyperbola with the coordinates 3 and 4. We're also given the vertical asymptote that goes through the x-axis at -1, as well as the horizontal asymptote that goes through the y-axis at 3. So how will we determine the equation of an hyperbola? Well, we start with the general form. So we write down fx is equal to a over x plus p plus q. And now from the information, we can fill in the values for p and q. So p is our vertical asymptote, but with the opposite sign, right? So we go down the vertical asymptote, it goes through the x-axis at -1. So in the place of p, we're going to put a +1. So in the place of p, we write +1. And then our horizontal asymptote goes through the y-axis at 3. So in the place of q, we put the value just as it is here, which is a +3. Okay, so far so good. Now we only need to determine the value of a to be done. So how will we do that? Well, we are going to put values in the place of x and y. And where will we get that from? From this extra point on the hyperbola. So in the place of this x, we're going to put the x coordinate. And in the place of the y, we're going to put this 4, which is the y coordinate. So let's do that. This 3 goes into the place of x, there we go. And this 4 goes into the place of y, and there it is. And now we simply solve for a. So this positive 3 goes to the other side, it becomes a -3. So 4 minus 3 is a 1. And then at the bottom here, we've got 3 plus 1, which is 4. So we end up with a over 4. And to get the value of a, since we're dividing here with a 4, we can multiply with it on the other side. So 4 is equal to a. So our a value is 4. And now we are done. So therefore, fx is equal to, and in the place of a, we can put the 4. There we go. And then we've got x plus 1. And in the place of q, we had the +3. And we are done. So this is the equation for our hyperbola. Now, I just want to quickly revise the following also. What will be the equations for the symmetry lines of this hyperbola or this equation? Now, let's have a look. If you remember from our previous lesson, we want to remember the original symmetry lines before there are any left or right movements or up and down movements. So our positive symmetry line, or the original positive symmetry line, is y equals x. And we know whatever happens to an hyperbola happens to the symmetry line. So what happened to this hyperbola? It moved 1 place to the left and 3 places up. And that's what we're going to do to the symmetry line. So in the place of x, we put these values as they are here. So in the place of x, we're going to put x plus 1. And then outside the brackets, we're going to put the upward movement, which was 3 movements up, so +3. And once we multiply this 1 in with the brackets and we do the math, well, we end up with y equals x plus 4. And there is our positive symmetry line. And what will the negative symmetry lines equation be? Well, that's quite easy too. So the original negative symmetry line is y equals -x. This is the negative symmetry line before there was any left or right or up and down movements. So whatever happened to the hyperbola needs to happen to this negative symmetry line. So this hyperbola moved 1 place to the left and 3 places up, and that's what we're going to do to this. So in the place of x, we're going to put x plus 1. So we're going to write down the minus, and in the place of x, x plus 1, and we're going to put this +3 on the outside. There we go. Then we're going to use the distributive law to multiply in the minus, and we're going to add the constants, and then we end up with a negative symmetry line of y equals -x plus 2. Now, just to show you that we are correct, let's have a look at this positive symmetry line. If I go draw it in, it's going to go up like this. And since the y-intercept is a +4, look, it should be because it goes through the y-axis there at 4. And then our negative symmetry line with the negative gradient, well, it goes like this all the way down, downward sloping. And since it has a y-intercept of +2, look where it goes through our y-axis. It seems like it should be a +2, so we know we are correct. Okay, excellent. So I hope you could follow and see you again next time. Bye.